No one saw this coming. Not Elon Musk, not Wall Street, and not the trillion-dollar electric vehicle industry racing toward a battery-powered future. Because this story didn't emerge from Silicon Valley headlines, it reportedly surfaced from deep within Honda's highly secretive R&D facilities in Chigi, Japan. No flashy launch event, no dramatic keynote speech, just a hidden prototype and an idea that was never expected to leave the lab. At first, you expect the usual EV formula: giant batteries, charging cables, long waits at charging stations, and constant concern about driving range. But instead, Honda is rumored to have developed something entirely different: a self-generating hybrid system. No massive EV drivetrain, no charging port, and no dependence on external charging infrastructure. Within just 48 hours of the leak, markets reportedly reacted sharply. Billions were wiped from major EV-related companies, with Tesla, Rivian, and Panasonic all feeling the pressure. What Honda's CEO allegedly revealed wasn't just another upgrade to hybrid technology. It was a direct challenge to the entire electric vehicle philosophy. No reliance on superchargers, no overloaded power grids, and no fragile supply chains tied to rare earth materials. Instead, the system focuses on a lightweight, highly efficient hybrid unit capable of generating its own power while driving. The concept is built around a closed-loop energy system designed to maximize efficiency. Waste heat that normally disappears into the air is captured and reused. Kinetic energy usually lost through friction is recovered and converted into electricity in real time. Rather than depending heavily on large batteries, the vehicle continuously recycles energy while running. According to early reports, the system could achieve fuel consumption figures close to 5 liters per 100 kilometers, while electric assistance reduces fuel usage by more than 40%. That means fewer worries about range, less dependence on charging networks, and reduced pressure on lithium mining and global battery supply chains. Honda also claims the technology can perform reliably in extreme conditions, from scorching deserts to freezing mountain roads, without requiring fast chargers or specialized home charging systems. In theory, drivers could travel across entire countries without ever plugging the vehicle in. If these claims prove true, the implications could be enormous. And that raises an important question. Why is the public only hearing about this now? To understand that, you have to go back nearly 2 decades to 2008. At the time, the world was rapidly embracing lithium batteries and fully electric vehicles as the inevitable future. Quietly, however, Honda reportedly launched a secret initiative known as Project HX Prime. While most automakers were investing heavily in larger batteries and faster charging technology, Honda engineers were asking a different question. What happens if the electrical grid can't support a fully electric future? Honda already had extensive experience with hybrid systems and understood the balance between efficiency and practicality. The company reportedly anticipated future problems: strained infrastructure, dependence on mining operations, and increasing pressure from global supply chains. Instead of following the crowd, Honda allegedly focused on developing a next-generation hybrid platform capable of operating independently of large charging networks and battery shortages. By 2012, insiders claim working prototypes already existed, complete with real-world testing data. And then, suddenly, the project disappeared from public view. There was no official cancellation, no announcement of failure, and no explanation. According to industry rumors, the issue wasn't technical, it was political. Powerful interests tied to oil markets, battery manufacturing, and large-scale EV investments allegedly saw self-charging hybrid technology as a threat to supply chains and business models worth billions of dollars. If a highly efficient self-charging hybrid became viable, it could disrupt industries built around battery production, charging infrastructure, and raw material extraction. And if that disruption becomes reality, the future of transportation may no longer belong exclusively to fully electric vehicles, but to a new generation of intelligent hybrid systems. Honda reportedly made a calculated decision to step back. Engineers involved in the project were reassigned, and many were redirected toward the much safer and more politically acceptable hydrogen fuel cell programs. Hydrogen technology was easier to regulate, easier to control, and easier to delay. So for a while, the industry embraced it. But by 2024, serious cracks in the electric vehicle narrative were becoming impossible to ignore. Battery fires were making global headlines. Power grids were struggling under growing charging demand. Reports about environmental damage and controversial lithium mining operations across Africa and South America were spreading rapidly. That's when Honda's leadership allegedly saw an opportunity they hadn't considered in years. In early 2025, Project HX Prime was reportedly brought back. Not redesigned from scratch, but rediscovered. According to insiders, 3 prototype vehicles had been preserved inside a secure temperature-controlled facility in Tochigi Prefecture for over a decade. Engineers updated the software, modernized components, improved materials, and within just 5 months, the revived prototype was back on the road. The results reportedly shocked even Honda's own engineers. The vehicle could accelerate from 0 to 60 miles per hour in just 4.3 seconds, placing it firmly in modern EV performance territory. It reached a top speed of around 180 kilometers per hour, while maintaining strong torque delivery without the power drop-offs often associated with electric systems under strain. But the most surprising figure was the driving range. Approximately 760 kilometers on a single tank of fuel, all without requiring a charging cable, plug, or charging station. Refueling reportedly took less than 3 minutes. While many EV owners spend time planning charging stops and monitoring battery range, this system aimed to deliver the convenience of traditional fueling combined with hybrid efficiency. Honda engineers also claimed the platform experienced 42% less wear than conventional internal combustion engine systems. According to reports, the secret lies in how the system manages energy. The engine operates cooler and more efficiently, while energy is continuously regenerated internally. Unlike large lithium-ion batteries, the system avoids deep charge cycles and reduces long-term battery degradation issues. What once looked like an abandoned experimental project from the early 2000s was suddenly being discussed as a serious challenge to the EV industry, and the impact reportedly spread far beyond Japan. Inside major EV companies and battery manufacturers, concern began to grow. Expensive battery production facilities, once viewed as essential to the future, suddenly looked less secure if self-generating hybrid systems became commercially successful. Materials like lithium, cobalt, and nickel, critical to EV production, could become far less important. Executives from companies such as Tesla, Rivian, Lucid, and even traditional automakers like GM were reportedly called into urgent meetings shortly after the leak surfaced. The concern wasn't just about competition. It was about infrastructure itself. If vehicles no longer depended heavily on charging networks, entire ecosystems built around public charging stations and battery recycling could face major disruption. Then came the financial details that intensified the discussion. Reports claimed the powertrain could cost around $1,320 to produce, less than one-third the cost of many modern EV drivetrains. Instead of a massive battery pack and complex high-voltage systems, the design allegedly used a compact hybrid engine, a highly efficient regenerative energy unit, and a small supercapacitor array. Operating costs were estimated at roughly 0.8 cents per mile, dramatically lower than many current EVs. Lifetime emissions were also rumored to be significantly lower due to reduced battery manufacturing requirements and improved fuel efficiency. Perhaps most surprising was the reported break-even period, around 1.4 years. According to the claims, that's how long an average driver would need to recover the additional purchase cost through fuel savings alone. After that point, day-to-day transportation costs would become extremely low. Naturally, attention quickly turned toward the technology itself. At the center of the system was something many engineers once considered unrealistic: a thermal regenerative piezoelectric drive system. The concept reportedly works by capturing forms of energy that are normally wasted during driving. Instead of only burning fuel for propulsion, the engine also harvests high-frequency vibrations, exhaust heat, and pressure fluctuations produced during operation. Rather than storing huge amounts of energy inside large batteries, the system continuously converts those wasted forces into usable electrical energy in real time. The combustion engine reportedly operates in its most efficient performance range, while motion, heat, and pressure are constantly transformed into electricity. That energy is then directed into a compact supercapacitor array that powers the vehicle's systems, torque assistance, and electrical components. Honda engineers also claimed the system performed reliably in harsh conditions, including cold starts at temperatures as low as -22 degrees Celsius. Laboratory testing allegedly showed extremely low emissions, with only minimal vapor and near-zero CO2 output under certain conditions. On cold mornings, reports suggested the vehicle produced little more than warm air and light steam from the exhaust. In essence, the machine was designed to generate, store, and recycle energy continuously while driving, creating a highly efficient closed-loop system that turns wasted motion and heat back into usable power. So why hasn't the world embraced this technology? Yet, according to the rumors surrounding the leak, the answer is simple. Powerful industries and governments are deeply concerned about what it could mean. Within 48 hours of the information surfacing, reports claimed that European Union regulators began reviewing hybrid efficiency standards and synthetic combustion classifications. To many observers, it looked like an attempt to slow down or tightly control the technology before it could spread further. In the United States, oil industry lobbyists reportedly reacted with alarm. Publicly, some dismissed the project as nothing more than a publicity stunt. Privately, however, there were claims of emergency discussions surrounding fuel taxes and long-term energy policy. One rumor even suggested that a proposal was drafted to tax highly efficient thermal energy systems, essentially placing taxes on advanced engine efficiency itself. Meanwhile, China reportedly moved quickly behind the scenes. Automotive research divisions were said to be retrieving old hybrid engineering archives and accelerating reverse engineering programs. Japanese officials allegedly received warnings that intellectual property theft was no longer just a possibility, but an inevitability. Then attention shifted toward Tesla. Shortly after the leak, reports claimed that planned drivetrain upgrades for the Cybertruck had suddenly been paused without explanation. Industry insiders speculated that Tesla leadership wanted to fully understand Honda's alleged hybrid breakthrough before committing further to existing EV strategies. Because if even part of these claims proved accurate, the consequences could be enormous. This wasn't just about competing with electric vehicles. It was about challenging the global structure of modern energy itself. A highly efficient, self-generating hybrid system would reduce dependence on lithium, rare earth minerals, large charging networks, and vulnerable power grids. That possibility alone was enough to create concern across governments and industries worldwide. Unlike centralized charging infrastructure, This type of technology could operate almost independently. It wouldn't rely heavily on massive battery supply chains or vulnerable electrical grids. And when transportation becomes more self-sufficient, the impact extends far beyond the automotive world. The first major reaction reportedly came from financial markets. Hours after the leak, oil-related stocks experienced sharp declines. Saudi Aramco reportedly lost tens of billions in market value in a single trading day. Large investment funds also began reassessing lithium-related investments as uncertainty spread across the EV sector. For years, battery electric vehicles had been presented as the uncontested future of transportation. Suddenly, investors were forced to consider an entirely different possibility. India was reportedly among the first countries to respond strategically. Rumors suggested discussions were already underway to position the country as a major manufacturing hub for advanced hybrid engines by 2026. Leaked reports also hinted at meetings between Honda's Asia-Pacific division and Indian officials regarding fuel-efficient transportation systems for rural regions and difficult mountainous terrain. At the same time, Honda's stock price reportedly surged dramatically, recording one of the strongest gains in the company's modern history. Then came another unexpected development: Russia. According to speculation from unnamed insiders, Russian defense planners allegedly showed interest in adapting the technology for military logistics vehicles, armored transport systems, and even autonomous underwater equipment due to its efficiency and reduced infrastructure dependence. But the biggest shock came shortly afterward. In early June, anonymous engineers believed to be connected to a former subcontractor team reportedly uploaded detailed schematics of the thermal regenerative hybrid capacitor system to an online whistleblower forum. Within hours, millions of downloads were recorded. Soon after, Japan's patent office reportedly confirmed that similar technology had briefly appeared in patent filings during 2023 before quietly disappearing. At that point, many observers began questioning whether Honda's long silence had really been voluntary. Leaked internal documents from Tochigi and Hamamatsu allegedly revealed something even more ambitious. And this is where the story reportedly moved beyond automobiles altogether. According to the claims, Honda had not limited testing to laboratories or controlled demonstrations. Instead, the company allegedly deployed multiple hidden test fleets across 3 different continents using shell companies and untraceable registrations. One prototype was reportedly tested in rural Kenya under extremely harsh conditions, including rough roads, high temperatures, and dramatic altitude changes that normally place severe stress on conventional drivetrains. The results allegedly showed no measurable performance degradation. Even more surprising were reports from sealed environment testing. Vehicles were supposedly operated in tunnels, underground facilities, and low-ventilation environments where traditional combustion engines typically produce dangerous emissions. According to leaked lab results, emissions were nearly non-existent, not merely within regulations, but reportedly close to zero. Testers claimed they detected almost no carbon dioxide, nitrogen oxides, soot, or unburned hydrocarbons. There was little visible exhaust, no noticeable odor, and only faint heat vapor exiting the system. Some reports even suggested that engineers initially believed their testing equipment had malfunctioned because the readings were so unexpectedly clean. But this is where the story takes another unexpected turn, because breakthrough technology often creates entirely new challenges. The focus is no longer just about oil, electricity, or battery capacity. According to analysts following the leak, thermal efficiency itself could become one of the world's most valuable strategic resources. That changes the conversation completely. Regions already struggling with energy pressures, including parts of California and sub-Saharan Africa, may soon face a different kind of challenge. Instead of asking how to generate enough electricity for massive charging networks, governments could be forced to rethink how to manage a future built around distributed, self-sustaining transportation systems. Experts warn that demand for highly efficient fuels, advanced alloys, and precision-engineered materials could quickly overwhelm supply chains that were never designed for this type of technology. The world may be entering a phase no existing economic model fully anticipated. Future global competition might no longer revolve around oil pipelines or power grids, but around control of next-generation propulsion systems and the materials required to build them. And despite all the excitement, this technology reportedly isn't simple or inexpensive to manufacture. The core system allegedly depends on specialized corrosion-resistant alloys and custom piezoelectric materials. These materials are not necessarily rare, but they are highly specialized and difficult to scale quickly. Early estimates suggest production costs could initially be around 15% higher than traditional systems due to manufacturing complexity. That creates another problem. The global industrial supply chain may not yet be prepared for sudden mass adoption. Even insurance companies are reportedly struggling to classify the technology. It doesn't fit neatly into existing categories. It's not a fully electric vehicle, not a traditional combustion engine, and not a standard hybrid by current definitions. In many ways, it sits in a regulatory gray area that governments haven't prepared for. There are already rumors that some municipal authorities are considering fuel distribution controls, thermal efficiency limits, and other policies aimed at slowing disruption to existing transportation infrastructure. If those measures appear, the consequences could be massive. Expansion plans for EV charging networks might slow down. Electrical substation upgrades could lose priority. Large battery storage projects could suddenly become less urgent. After all, if a new propulsion system makes existing infrastructure less necessary, governments and industries may hesitate before investing billions more into older technology paths. And according to reports, the momentum is only growing. Honda is expected to officially present the technology at the next Tokyo Auto Show, not as a futuristic concept, but alongside real production plans. Early rollout markets are rumored to include Asia and the Middle East, regions that were often criticized for slower EV adoption, but may have simply been waiting for a more practical, long-term solution. Meanwhile, one of the most talked-about reactions has been Elon Musk's silence. No social media posts, no public criticism, no jokes, despite the fact that this alleged technology could directly challenge Tesla's long-term vision. Industry insiders claim some Cybertruck drivetrain developments remain under review as companies reassess future strategies. At the same time, automakers in Detroit and Seoul are reportedly moving urgently behind closed doors. Emergency meetings, quiet negotiations with governments, and rapid planning sessions are allegedly underway as companies explore how quickly they can pivot toward advanced hybrid systems. Some reports even suggest certain manufacturers are seeking financial support, not because they're collapsing, but because they fear falling behind in a rapidly changing market. Honda, however, appears to be accelerating. Rumors indicate that the company recently submitted a production roadmap to Japan's Ministry of Economy with a goal of producing 1 million next-generation hybrid engines annually by 2027. If true, this isn't just another development in the automotive industry, it's a major reset. From Detroit to Dubai, from charging networks to lithium mines, from grid expansion projects to battery factories, industries that once seemed untouchable are suddenly being questioned. And if this technology truly delivers on its promises, the transition may happen quietly, not through massive marketing campaigns or dramatic announcements, but through something far simpler: turning a key, hearing the steady hum of an ultra-efficient regenerative hybrid engine, and driving without worrying about charging stations at all. Because if this is only the beginning, the real battle won't just be about the future of cars. It will be about who controls the future of transportation itself.